Right, so today's transformations part 3. And this is where we left off last week. Elizabeth was a pirate. You'll see her in the water there. And her pirate ship got attacked by one of the queens. Right, and I believe the timeline was 17 something. I can't remember the exact timeline. The name of her boat was the Devil's Dutchman, and she was thrown overboard in the attack. Right. And remember, the British ship, the Queen's ship, rescued her, but only to punish her, to throw her on a deserted, rocky, small island where she would hopefully starve to death or die of thirst until a bottle with a message came floating around. Right? Now, it seems that the message in the bottle was from another stranded soldier somewhere close to her marooned spot. And of course, so close to death and desperate, Elizabeth dived into the water and swam, well, swim, no, swam, I even know the past tense, swim, swimmed in the direction that the bottle came from, hoping to find the abandoned sailor so she can have, some company, okay? All right. Yeah, it's swamp, right? Somebody's reminding me. All right. So let's get started with the first question. Today we are going to do something called enlargements, okay? Now here's what I need for you all to do, right? You don't need to draw anything on the screen. I know most of you all may not have any graph paper, but I just need you to follow along. So we have something called enlargement. What do you all think an enlargement is? An enlargement is when you make a shape larger. In other words, you change the size of the shape, okay? So today we have a triangle. And the triangle, well, it's A, B, and C. When we're finished doing this thing called an enlargement, that triangle on the screen should look larger. In the exam, the examiner will make it very, very specific of how much times larger the shape is supposed to get. So in my first question today, if you read the instructions up here, right, we get a different color, we get yellow. We want to enlarge ABC by a scale factor of 3. Now, those are some fancy words, right? But all it means is that we want to make that triangle 3 times larger. Now, there are 2 ways, right? We can make it 3 times larger. We could use the drawing method, or we could use the matrices. Well, which one do you all think would be easier? If we had 2 methods to choose, which one do you think from experience, right? Because we've been doing a lot of transformations over the past 3 weeks, right? Which one do you think will be easier? The drawing method, where we use a pencil and a ruler, or the matrices? Whenever you are doing an enlargement, you have to know where the center of enlargement is. And that's going to be very important. Whenever we're doing an enlargement, the most popular type of question is when the center of enlargement is the origin. So some of you are probably wondering, what is the center of enlargement? Well, as I mentioned, in today's question, the center of enlargement is the origin. In a graph, you all know what the y and x axis is, right? Let's write it in x and y. The origin is over here. I put in a pink dot. So today, when we're doing the enlargement, since the examiner told us the center of enlargement is the origin, we are going to pretend we are standing up by the origin, by the point 0, 0. Quick question. If I have a line and I tell you the length of this line is 4 centimeters. And I tell you, right, and let's say the beginning of the line is A and the end of the line is B. And I tell you, I want to make that line 3 times larger. What would be the length of the line? If I were to make it 3 times larger? I know it seems like a very simple question, but it could be misinterpreted. What would be the length of AB if I were to make it 3 times larger? Most people are saying 12, right? And that is the correct answer, because if you take 4 and multiply it by 3, you will get 12 centimeters. So that means to make this line, which starts at A, 3 times larger, the final length of the line, like if we extend it, let's go up to C. The full length of the line would be 12 centimeters. From A to C would be 12 centimeters. And like I said, that is the correct answer. But how did we make it 12 centimeters, right? And this is where I used to confuse it. I go from A to B. I already have 4 centimeters. Remember, the final length to make it 3 times larger has to be 12 centimeters, correct? So that means I already have 4. So I move another 4. That's another 4 centimeters. And then I move another 4. And that would make the full length how much? 12. But here's what I used to do wrong in school. Let me do it back underneath here. If I have a line AB, right? And the line was 4 centimeters. And the examiner told me to make it 3 times longer. Here's what I did by mistake. And not only me, a lot of people. I would go 4 centimeters and another 4 centimeters and another 4 centimeters. Because they told me to make it 3 times longer. So I put 3 extra 4 centimeters. But if I put 3 extra 4 centimeters, what is the full length of the line in my wrong analysis? And the full length is 16, 4 plus 4 plus 4 plus 4. The full length would be 16. I did not make it 3 times longer. I made it how much times longer by mistake? 4 times longer. You see, when you have to make something like something times longer, like in 3 times longer, the first measurement counts as 1, and the additional ones count as 2. So the original 1 plus the 2 extra 4 makes it 3. That's very important to know that the first length counts as 1. And then if you ask it, in other words, if you ask me to make a line twice as long, and the original length of the line was 5 centimeters, and I told you to make it twice as long, the final length has to be what? 10 centimeters, because the first 5 centimeters counts as 1, and the additional 5 centimeters counts as another 1. 1 plus 1 is 2, twice. Great. So we're going to apply that concept now to this triangle. The first thing you want to do, if they tell you the center of enlargement is 3, you want, look at it. It has 3 points, right? A, B, and C. You're going to connect each point. I'm going to start with A to the origin. And you see this length here? You're going to use your ruler to draw that line, right? Let's just say the length of that line is 4 centimeters. I actually don't know the length of the line, but you can use a ruler. What we are going to do is extend this red line from the origin, because the examiner told us to do it from the origin, to point A. And since it's 3 times larger, we are going to extend that line 2 more times, not 3 more times, because the original red line counts as 1. So we're going to use our ruler and maintain a straight line and put in 4 centimeters and then another 4 centimeters. You think you all can imagine that? Well, you don't have to imagine it. I'm going to do it for you now. Well, we're going to start off with point B. It doesn't matter which point you start off, but I started off with point B. So I'm going to take my ruler and connect the origin to point B, and then I'm going to measure the length of that line. And then I'm going to extend it twice. Look at the animation. Huh? That's 1 more extension, and then 1 more extension. You all see I extended it twice. From here to here is 1 extension. I don't know the length of that line. You will have to use your ruler in the exam. Let's just assume that this is 5.3 centimeters. I just assume it. Then we have to use our ruler and measure another 5.3 centimeters and then another 5.3 centimeters. Isn't that an extension of 3? Because the first one counts as 1, the next one counts as 2, and the next one counts as what? 3. And we do that for all the points, okay? So when we extended this by 3, the final point ended up here. We're going to do the same thing for point A. Sorry, I'm doing point C. Sorry, I made a mistake, right? So you all see the blue line? In case you can't see it, from here to here, we're going to have to use our ruler and measure that length. It might be looking like about 2 centimeters or 1.5 centimeters. We have to extend that line 2 more times. So look carefully. You'll see another blue line just up here, right? And then we're going to extend it 1 more time, making the total extension what? 3. And that point ends up here. And now we're going to do the same thing for point A. From the origin, we're going to take our ruler and connect it to A. That's the green line. We're going to measure the length of that green line and then extend it 2 more times. 1, 2. And that ends up over here. And then we connect all 3 final points. And look at the orange triangle. Doesn't the orange triangle look about 3 times larger than the original triangle? And you all notice if you backtrack all the lines, if you backtrack the green line, the red line, and the blue line, all 3 lines end up going through or lining up with the origin. It comes like a ray of light, a burst of light, expanding out from the origin, right? But how do we know it's that triangle is exactly 3 times larger? Well, it's real easy. We could just take one side of the triangle, just do a little test run, right? Let me just go. If we take from here to here, right? How much blocks is that? Isn't that 1 block, 2 block from A to C? Do we all agree? Isn't that 2 blocks? 1 block, 2 block? Go from here to here now. And how much blocks do you all see? From here to here. 1, 2, 3, 4, 5, 6. So from here to here is 6 blocks, and from here to here is 2 blocks. Isn't 6 3 times larger than 2? And you can do that for any side. For a straight line, it's easy. So what you could do is measure the length of this line with a ruler, and you will notice it's 3 times larger than this line. Right? But you just need to take one side and do a test run. Choose any one side and just measure it and make sure it's 3 times larger than the corresponding side. Now, how do we label this triangle for the examiner, right? Well, if this point here is A, then A go up here. So he is what? A prime. Won't he have coordinates? What's his coordinates? 3, 6. 3, 9, sorry. 3 on the X, 9 on the Y. If he is point B, then when he grows up or becomes bigger, he becomes B prime. And what are his coordinates? 12, 6. And what do you call this point? He will be C prime, because he used to be C down here, 1, 1, and then he got 3 times larger. So he is 3, 3. Right? You think you're, and we have more examples, but you think you'll get the general understanding of this, right? I want you all to take down this note here to the left-hand side of the screen, right? I think that's the best I could explain it. I don't think I could do a better job, right? Let's say I'm going to erase something, right? Let me just erase the original triangle. You see the original blue triangle? Let me just erase that for you guys there. I know you all can still see it a little bit, right? Let me just see if I can put back the colors here, right? Oops. Get a blue. All right. So let's just say somebody now, right? Let's say somebody now joins class, right? They know the bouncing late. And I erase the original triangle. Do you all think there is a way to get back the original triangle? The orange one is the already enlarged triangle. It has already been made 3 times larger. Do you think there is a way to get back the original triangle, right? And obviously, yes, right? There must be a way. So here's the easiest way to go about it. If you know that this triangle was made 3 times larger, and the center of origin was the center of enlargement was the origin, all you have to do is measure. Let's start off with the green line. We would take our ruler and measure the length of the green line, right? We would measure the length of the green line. Let's just say, I'm just assuming, right? The length of the green line ended up being 15 centimeters, all right? We know it got 3 times larger. What number would you divide the 15 by to get back the original triangle, knowing that it was made 3 times larger? And common sense would say 3. So you would take the 15 and divide it by what? 3. And 15 divided by 3 is 5. So guess what you would do? From the origin, you would measure how much centimeters? 5 centimeters. And that will give you the original point of A prime, which is A. And you do the same thing for what? The blue. For the blue, which is C prime, let's say we measure the length of that line. I'm not running out of space here. Let's say the length of that line was 8 centimeters. We know it got 3 times larger. So the original line, its length, is supposed to be 3 times smaller. So you would take the 8 and divide it by 3. So 8 divided by 3 is roughly 2.7 centimeters. You would take your ruler and measure what? 2.7 centimeters. And that will give you the origin. So from the origin to point C, the length of that portion of the line would be 2.7. And you do the same thing for what? The red line. You just simply divide it by whatever the enlargement was. So if the enlargement was 4, you divide the original, the full length of the line by 4. If it was twice as long, you divide the whole length of the line by 2. Really, really simple. And don't worry, I actually have another example where I give you the final triangle and you trying to get back the original triangle. So you'll hear me say it again, okay? And it will stick forever in your minds, right? Now, let's continue the story here, right? By the way, there's another way to do the enlargement. There is another way, and we will get to that just now. So if you all look closely, you all will see Elizabeth on the shores here. So apparently Elizabeth, well, she's a pirate, so she must be a very strong swimmer, right? So she followed the instructions on the bottle and swam, right? So let's see what happens here. She eventually reached the island after swimming for hours. When she reached the shore, she was so exhausted that she passed out on the sand. She was later awakened by an abandoned sailor. Remember, the message on the bottle came from another stranded sailor on another island. His name was Captain Fletcher Christian. It's finally good to have someone to talk to after all of these years. So he's probably been stranded there for years. Okay. Anybody knows where this name comes from? For those who read a lot of books, where does the name Fletcher Christian come from? It's a name from a real popular book. Anybody wants to take a guess? They both knew what would eventually happen. Well, what do you guys think happened? The island began to shake and tremors now. The island was constantly shaking. Anybody knows what the tremors mean? Maybe the island had what? A volcano on it and it exploded, right? So we're going to see what happened after 28 years on the island, right? Christian Fletcher, but by the way, I changed around his name. It's supposed to be Christian Fletcher, not Fletcher Christian. It's from a book, a very popular book, HSM Bounty. Mutiny on HMS Bounty, right? And it's actually based on a true story, right? About a man who led a mutiny on a ship and he kicked out his captain and whatnot, right? Whenever y'all get a chance, you can probably read that book or watch the movie. It's pretty good. All right, so let's move on. Yeah, he was an English sailor. So a lot of you all are telling me, well, there's an easier way to enlarge something, right? Like if you wanted to enlarge it by 3, you could have just take all the coordinates and multiply it by what? 3. And that is true, right? But you could use the matrices method. Now look at this new question. We want to take this triangle and enlarge it by a factor of 2. That means we want to make this triangle 3 times larger. Now, look at the other piece of instructions. They want us to assume the center of enlargement is the origin. If you look back in your notes on the first day of class, I want you all to physically turn back. Can you all spot this matrix C in your notes? Just don't say yes, sir. I want you to physically go back and find the enlargement matrix, K00K. And let me know when you spot it in your notes from the first day of class. Well, like I said, these notes were given about almost 3 weeks ago. So here's the thing. If you do not want to draw lines, like if I'm just saying, right? Here's the origin, right? If I wanted to make this 2 times larger, because they told us the scale factor is 2, I could draw a line from the origin to point A. Let's just say that the length of this line was 7 centimeters when I use my ruler. How much more times would I have to extend that centimeters? In other words, what would be the full length of the pink line if I were to make it 2 times larger, if I'm aiming? You would have to, right, you'll have to extend it 1 more time, right? You'll have to extend it 1 more 7 centimeters, making the total length 14 centimeters from the origin. Because today we are enlarging it by a factor of what? 2. And we would do that for all the lines, right? We would draw a line from the origin to point B, measure the length with our rulers, and then extend it by that 1 more time. But Let's say the examiner doesn't want us to use the drawing method. He says, hey, you have to use the enlargement method. If I'm using the enlargement method and I say you want to enlarge it by a factor of 2, what do you think you're going to replace the letter K with? It's not even a trick question. If they want you to enlarge it by a factor of 2, we replace the letter K with what? 2. If I had asked you to make it 3 times larger, you would replace the 2 Ks with 3. If I ask you to make it 4 times larger, you replace the letter K with 4. And the zeros just remain as zeros. These two will always be 0. And here's what you have to do. And I want you all to actually do it. Just to say, you could have done it. I want you to take this matrix and multiply it by point A. Now, when you're multiplying it by point A, you have to write A vertical. I think you all know this already. A is 1 minus 2. So you write it like this with the x coordinate on top and the y coordinate underneath. This is A prime. This is A, by the way. Take this matrix 2002 and multiply it by point A and tell me what you get. You will get A prime, but I want you to physically do it. Let the minus 2 swing up to the top, walk it across, and get the 2 answers here for me. Right, I just muted myself for a few seconds. Revision. But not too slowly, because we had 3 weeks to prepare how to multiply matrices. So the minus 2 swings up to the top. The 1 and the minus 2 walk across. They get photocopied, right? So we take each one here and we multiply it. Each pair and multiply it. Right? 1 by 2 is 2. Minus 2 by 0 is 0. 0 by 1 is 0. 2 multiplied by minus 2 is minus 4. To get the answer on top, we add the 2 values on top. 2 plus 0 is 2. 0 plus minus 4 is minus 4. So A prime, remember the top is X and the underneath is Y. So I could plot A prime on the graph here. Go to the X coordinate is 2, 2, and we go down to minus 4. This is A prime, all right, in the team? So some people notice a pattern here, right? If we are making it 2 times larger, and the center of enlargement is the origin, and all we did was take the A coordinates and multiply by 2. You all see that? 1 multiplied by 2 is 2, and minus 2 multiplied by 2 is minus 4. You all see that pattern, right? All you are doing is taking the X and Y coordinates and multiplying it by 2. Now, let's say the examiner says, do not do the drawing method, and he wants you to use the calculation method. Do you think it's okay just to visit all the points and multiply it by 2? Do you think that is okay? No, you won't get the marks in the exam. If the examiner wants you to use a calculation method, he's really trying to say use the matrix C method. So you're going to have to use this matrix C here, right? You're going to have to use the matrix C method and show the examiner, right, that you are multiplying each point by that matrix C. You have to, in order to get the points, okay? So now, I'm not going to make you do all, right? But to calculate point B, you would put the matrix C, 2, 0, 0, 2, and then multiplied by point B, which is 3 minus 2. Once again, the X coordinate goes on top and the Y coordinate goes underneath, okay? When you take this matrix and multiply it by this, I guarantee you, if you take your time and let everybody swing up to the top and move it across, you all know we're going to get 6 and what? Minus 4. And we will plot that point, right? Let me plot 6 minus 4. 6, and we go down to where? Minus 4. And if we do the same thing for point C, if we take this matrix and multiply it by point C, we're going to get 6 minus 6. So 6, and we go down to where? Minus 6. And when we connect those points, the triangle will look twice as big. Now, it's very, very important to know, right, that this matrix only works if the center of enlargement is the origin. That's super important to know. If the examiner says that the center of enlargement is not the origin, like it's a totally different point from the origin, you cannot use this formula. The only way on the CXC syllabus to do an enlargement that is not the origin is via the drawing method. So to me, the drawing method is actually a little bit more powerful for enlargements because, like I said, this enlargement formula only works if the center of enlargement is the origin. So I know some of you all are asking in your head, will Sir be doing an enlargement question where the center of enlargement is not the origin? Of course I will be. All right. I can't let you all go out like that, right? I have to give you all an example and show you where the center of enlargement is not the origin. All right. So for those who want to screenshot this, there isn't too much to take down here, right? I'm just showing you how to use the matrix C, which everyone here should be familiar with already, right? Great. Oh, quick question. Let's say somebody now joins class, right? And over here, now I told you the scale, the center, sorry, the enlargement is a factor of 2. So let's say this got scraped off. Do you think there is an easy way to figure out how much the scale factor is? The scale factor is how much times it got larger, right? Isn't that a super easy question? And all you have to do is measure the length of one side. Like if we measure the length from B to C, let's say when we measured it, we got 10 centimeters. Then we measure the length of a corresponding side. Let's say we got 5 centimeters. What's the scale factor? Isn't it 10 divided by 5? Because the 10 is twice as large as the 5. So to get the scale factor is super easy. You just take the length of 2 corresponding sides and divide it. And that will obviously tell you how much times it got what? Larger, right? Right, so screenshot if you need to screenshot, guys. I'm going to erase this. Let me know when you're finished. I know some of y'all are not going to screenshot. That is okay. All right. Let's see what the next slide holds for us. Right, so one morning they are week, about 28 months, and you can see they have a family and whatnot. They saw that the sea had retracted for many miles. They knew it was coming, and there was nowhere to run, as the island was just too small. They stood on the beach and waited for the inevitable. Well, it's obvious by now that when the beach or the ocean starts to what? Retract, we all know what's going to happen, right? It's a tsunami coming, right? So if you all see it there, the beach, it has retracted, so the sea, the sand underneath the ocean, and that's the tsunami headed. Closer and closer, right? And that's it, guys. They got washed away. This one does not have a happy ending. And that's Elizabeth's story, right? Clearly she's traumatized, and of course, that's why her bottle, message in the bottle, is the most precious item when she was living. It's because of that bottle and that message, she was able to Christian and raise a family on the island. All right? Right, and remember, whenever we listen to a ghost, they will give us some information about any crimes that are going to take place in the area, right? So let's move on. All right, so look at this question now, right? Enlarge the triangle. I'm going to write it back properly, don't worry. Enlarge ABC by a scale factor of 3. So what we want to do is make this triangle 3 times larger. But this time, the center of enlargement is not the origin. The center of enlargement today is -1, 3. That's somewhere over here. That's this point here. Isn't that the point -1, 3? I know it's kind of hard to see, but I'm just gonna write it here. And I have point A here. I'm gonna write back everything. Point A is 1, 0. Point C is how much? 3, 1. And point B is 3, 0. Tell me something. If the examiner were to ask us to enlarge this triangle by a scale factor of 3, can I use this formula? K 0, 0, K. In other words, since it's 3 times larger, I multiply all the points by 3, 0, 0, 3. I gave away the answer to that question just now. The answer is no. This formula only works if the center of enlargement is the origin. It only works if we're pretending we're standing at 0, 0. So the only way to get out this question is by the drawing method. And no, you cannot multiply each point by 3. That thing about multiplying each point by 3 only works if the center of enlargement is the origin. So all we have to do in a question like this now, instead of drawing all our lines from the origin, we draw it from the -1, 3, the point the examiner told us or wrote in the question paper. So here's what we're going to do. From the center of enlargement, which is -1, 3, we're going to draw a line. I kind of did it. I kind of fast-tracked it here a little bit, right? What we would do, I'm going to start with point C first. We would draw a line from -1, 3 and measure it on our rulers. Let's say the length from here to point C was 11 centimeters. Who could tell me what's the length from here to here? From C to the end of the line. What would be the length from there? No. Listen to the question good. I want to know the length from C, from point C to the end. I didn't ask you for the full length. I want to know the length from C to the end. Right. Won't it be 22 centimeters? I think some of you all are forgetting that when you're doing an enlargement, like an enlargement of factor 3, the first 11 counts as 1. The remainder of the line will be 2 or twice as long. Because what's the full length of the line now? 33. The full length of the line is 33. The first 11 centimeters counts as 1. The 22 will count as 2, making the full enlargement 3. Right? So if from the center of enlargement to point B was 8 centimeters, what would be the length from B to the end of the line? I hope everyone gets it correct now. From the center of enlargement to B is 8. How much would be the rest of the line? Keyword, the rest of the line. Right, 16 centimeters. The first 8 counts as 1, and well, 16 is twice 8. So 1, 2, 3. Okay? Great. And once we do that, right, or you'll get the idea, right? It's pretty simple from this point, right? We would connect all 3 ends of the final lines, right? And of course, is this triangle 3 times the size of this triangle? Yes, right? If we measure the length from here to here, you'll notice it's 3 blocks, right? 1, 2, 3. This one here is how much blocks? 1. So by comparing two corresponding sides, we immediately see it's 3 times larger, right? So whenever the moral of the story is this: whenever the center of enlargement is not the origin, you cannot use the matrix C method. You can't take the matrix C and multiply each point by the matrix C. That matrix C only works if the center of enlargement is the origin. If it's not the origin, well, unfortunately, you have to use the drawing method, right? And you all will see something, right? Remember, this was point C. C was how much? 3, 1. C prime is how much? This is 11 minus 3. Did multiplying it by 3 work? Like if we multiply this by 3 and we multiply this by 3, would we get 11 minus 3? The answer is no, right? So you all could see that multiply, if we want to make something 3 times larger, if the center of enlargement is not the origin, multiplying by 3 doesn't work either. Only the drawing method will work, okay? So screenshot if you need to, right? And I'm going to erase the wrong thing here, right? Screenshot if you want to. Let me know when you're finished. All right. In this question here, right? I know this one is kind of hard to see, right? Now, let me see if I can I'll put these 2 points, right? I'll put them in black. Right. Now, this triangle, I know you might need to put your finger on the screen. How much times do you think this triangle got enlarged by? What's the scale factor? Put your fingers on the screen and see if you can measure it and whatnot. What is the scale factor of this? Right. Look at this. From here to here is 1, 2. This is an easy line to compare, right? It's two blocks wide. And over here is how much? 1, 2, 3, 4. Isn't 4 twice the amount as 2? So to me, the scale factor is what? 2. All right? That's all you're doing. Or you can just take a ruler and physically measure it, right? So most likely, if you would have measured from here to here, you would have get 2 centimeters on proper graph paper. And then you measure from here to here, and you would have gotten 4 centimeters on proper graph paper. 4 is twice as large as what? 2, right? So 4 is twice as large as 2. So the scale factor is 2. But how do you figure out where the center of enlargement is? Like where is the center of enlargement? Tell me something. Does the center of enlargement always have to be the origin? Right. The center of enlargement doesn't always have to be the origin. So how do you find the center of enlargement, right? It's a real simple process, right? All you are going to do is connect 2 similar points. So let me give the point names, right? So I'm going to call this A prime and this A, right? Going to call him B, and this will be B prime after he got larger. And then you have point C, and when he got larger, he was what? C prime. Here's what you're going to do. You're going to connect similar points. A prime and A, we're going to take our ruler and connect them. But when we connect them, we're going to continue the line all the way to the end of the graph paper. So let's watch my animation here. You all see what I did there? Make sure you see it. Look at the green line. I connected A prime to A, And then you need a long ruler for this, right? When you connect A prime to A, extend it till the end of the graph paper. And you're going to do the same thing for all the other points. You're going to connect B prime to B, and then take a long ruler and continue the pattern, continue the straight line. So look at it. Look at B and B prime. You all see it there? I connect B prime to B, and I extended it all the way to the end of the graph paper. And guess what you're going to do? You're going to do the same thing for C and C prime. I connect C prime to C with a long ruler, and then I connected it, and then I extended it. You all realize something strange? Well, not strange, cool. Didn't all three lines come together at one point? Isn't that kind of strange? All three lines, when you backtrack it, met over here. And I know some of you are going to have trouble seeing this, right? But this is 4, and over here is 5. The coordinates of where all the lines meet is 4, 5. 4 on the X and 5 on the Y. That's the center of enlargement. That is where the enlargement originated from. To me, this is one of the easiest things to do in maths, right? So whenever they ask you to backtrack to find the center of enlargement, you connect similar points and extend it to the end of the graph paper. And if you do that for all the points of the shape, all of them will come together at one similar point. And you just read off the coordinates and you're good to go. Take a screenshot. Let me know when you are finished. And remember, guys, if you don't catch something, right, you could always review the recording, right? And you can always review sometimes. And I think I explained this in yesterday's class for integrated science, or one of those classes. I was actually one of those persons who don't always catch things on the first explanation. I never did. I usually have to go through something 3 times. And up to this day, I'm the same way. Whenever I'm revising or have to study and whatnot, my first thing is just to sit down in class, get a general idea of what's going on. And then I would rewatch. Well, in my days, they didn't have videos, right? You would reread the book, right? And then I'll write down some notes. And then by the 3rd time I review it, I catch it, right? Right. So some people are asking if the recordings will be available after summer. Nope. Sorry guys. After summer, all my recordings get locked behind passwords and are made private. Right? So all right. So here's another story now. Right? So we wait in the cemetery and wait a few hours again, and suddenly you see another ghost appear holding an arrow. But it's supposed to be a block of cheese. Sorry. This is supposed to be cheese. So introduce yourself as usual, and the ghost begins to talk. So this ghost is Jenny, and she's from 1477 in France. Anybody wants to one? How did Jenny meet and why so important to her? Anybody wants to take a guess? How did she meet and why is so important? Right. So according to this question, right, they gave us the center of enlargement, the larger triangle and whatnot. We are trying to find the original triangle. So the original triangle has to be smaller. We are trying to find a smaller triangle. And we cannot use the matrices method and whatnot, because the center of enlargement is not the origin. The center of enlargement was not O. So to do this question, the only way we could do it is by the drawing method. So here's what we're going to do. We're going to connect each point to the center of enlargement. So here's what I did. I took B prime and I connected it to the center of enlargement. What we will need to do is measure the length of that line. And after we measure the length of that line, what number you think we're going to divide it by? Take a guess. It's not even a trick question. If it got twice as large, we're going to divide it by 2. Correct. Okay? Now, let's say that from B to the center of enlargement, I call it the center of enlargement P. If the length of that line was 20 centimeters, the full length, we just divide it by 2 and we will get what? 10. And all we have to do is measure 10 centimeters from point P up the line. Okay? So you measure 10 centimeters from the center of enlargement. And guess what? We do that with all the points. We're going to connect one more point, point A, to the center of enlargement. And because it's twice as big, to get back the original, we divide it by 2. So we would measure the length of the blue line with our rulers, whatever we get. If we get 24 centimeters, we divide it by 2. And then half of 24 is 12. So from point P, you measure what? 12 centimeters. So from point P to this dot is 12 centimeters. And you do the same thing for point C. Measure the length of the red line with your ruler. Whatever you get, divided by 2, right? Right? And when you connect all of those points after dividing all the lines by 2, you will get what? A smaller triangle. Now, if the center of enlargement, if the enlargement was 3, instead of dividing by 2, you would do what? Divide, right, by 3. If the enlargement was 4, you measure the line and divide it by 4. But when you divide it by 4, you're always measuring from the center of enlargement and not from the triangular. You always measure it from the center of origin. Okay, not the other way around. All right. Take a screenshot if you need to. All right. Let's go. Yeah, somebody said they're fans. They come to support the channel. All right. The triangle is a result of an enlargement factor of 3, with the center of enlargement being minus 6.2. All right, so this is very, very similar to the previous question, right? But instead now, right, the enlargement factor is 3. So I'm going to call here A prime, B prime, and C prime. And they said the center of enlargement is minus 6.2. So that's over here. I know it's hard to see, but let's write it in minus 6.2. So they want us to kind of backtrack to the original triangle. The original triangle is obviously 3 times smaller. So it's the same concept. We're going to connect each point back to the center of enlargement, right? So I'm going to take point A. If you look at the screen, I connected point A to the center of enlargement. Once again, I know some of you already predicted what's going to happen. You would measure the length of the line. Let's say we use our ruler and we measured it, and we got 18 centimeters. What would we be dividing it by? Well, what are we going to divide the 18 by? Obviously, 3. 18 divided by 3 is 6. Where are we going to measure the 6 centimeters from? From point P or from point A prime? Where are we going to measure the 6 centimeters from? P or A prime? Come, guys, some of you are getting it wrong. Not the origin, guys. You measure it from the center of enlargement. Remember, the enlargement is starting from point P. So you're going to measure 6 centimeters from point P, right? From point P, not from A prime. Well, after you're divided by 2 or when you're divided by 3, the measurement starts from where the enlargement is originating. So let's make sure we get it correct now. We're going to connect B prime. Look at it. I connected B prime to the center of enlargement. The examiner told us what the center of enlargement was. If we were to measure the length of the blue line, let's say we got 21 centimeters. Since the center of enlargement is 3, we divide by 3 and we will get 7. The 7 centimeters needs to be measured from the point P. And you all get the idea here, right? We're going to connect C prime to where? P, that red dashed line, we're going to measure it on our rulers, divide it by 3, and then measure it from point B and put a dot. And if you were to do that for all of them, right? The original triangle is this red triangle here, right? And the distance from here to here, right? Quick question. If after we finish the question, if from here to here was, I'm just saying if it was 12 centimeters, what would be the length from here to here? It would be 24 centimeters, right? Right. Because 12 plus 24 is 36. 36 divided by 3 will give us what? 12, right? So whoever wants to take a screenshot can take a screenshot, right? All we basically doing is connecting back the line to the origination point and dividing it by 3, the length by 3, and then taking that divided unit after dividing it by 3 and measuring it from the point of origin. Right. All right, so let's go back to poor Jenny here, right? So let's see what's going on with Jenny. Oh, by the way, that's Jenny's parents here. They look very, very strict. Probably don't let WhatsApp or watch TV, right? One day, Jenny's parents said they needed to talk to her. They arranged for her to marry a wealthy baron. Great. If you all say this fast, it sounds like something, right? The great Count I'm so smelly. It sounds to be I'm so smelly, if you say it fast, right? And she would have to go and live with him. All right, that's a little hard luck there for Jenny, getting kicked out of her house by her parents, right? So apparently her parents were having another baby and she'll be needing her room. So they told her to get out, and they told her they never liked her in the first place. All right, so things are not going too good for Jenny. But don't worry, Jenny can always sing to make herself feel better. So after receiving the news, right, and plus talking to rats is really freaking them out, so they want her out of the house. So how does she respond to the news? Let's see.
Oh my gosh, this news is too terrible. I'm gonna need a miracle. Help me, about to go clinical.
All right, so that's Jenny there on her life there. All right, let's move on. Poor Jenny. I wonder how it's gonna go for her. Let's hear it one more time. Let's hear it.
Oh my gosh, this news is too terrible. I'm gonna need a miracle. Help me, about to go clinical.
Yeah, she sounds like Eminem there. But she won't be getting any awards soon. All right. What's the time here? 10:25. All right. Great. So we're going to do some rotations now. I doubt we're going to finish the rotation. I want you all to go back into your notes about 2 weeks or 3 weeks ago. I want you all to physically find this formula, right? I know I write it kind of small here. I'm going to try I'll just show you all how to use this formula. Cos theta minus sine theta, cos theta. Whenever you are rotating a shape, right, there's a special formula that you have to memorize for the exam, okay? There are two formulas that look very, very close to each other, okay? Whenever you are rotating something, you could either rotate it clockwise or the opposite way, anti-clockwise. Look very, very carefully here. The anti-clockwise matrix, the minus sign is by the top sine theta. If it's clockwise, in other words, not anti, the minus sign is be over here by the other sine theta. It's so easy to mix up. And guys, like I said, you all know my story. I didn't learn this in school because my head was hard, and I only got away because it didn't come for that year in the exam. Okay? So in this question, and you need your calculators now, so get your calculators out. Make sure that your calculators, right, on top of the screen, you're seeing D or DEG. Make sure you're seeing that at the top of your screen. If you are seeing R or RAD or G or GRAD, your calculator is on the wrong mode. Do a check, guys. I'm not going to be able to help you to change the mode of your calculator because everybody has a different calculator, right? But make sure, if you're not seeing that, quickly Google how to change it. Type in the model number of your calculator and figure out how to change the top of your calculator to D or DEG. Let me know that you are seeing D or DEG. D or DEG stands for degrees because we just measure angle in degrees, right? I'll write it a little bit bigger here, right? So if the examiner asks you to rotate a shape by 90 degrees and they say anti-clockwise, you go back into your memory and you remember cos theta minus sine theta, positive sine theta. By the way, it's cosine theta. Cos is short for cosine. If they tell you to rotate it by 90 degrees, guess what you do? All the thetas, all the funny looking symbols, you replace it with what? 90. It's not rocket science. So you write it like this. Cosine 90 degrees minus sine 90 degrees, sine 90 degrees, and positive cosine, 90 degrees. In other words, if they told you to rotate the triangle by 180 degrees or 270 degrees, whatever angle they tell you to rotate it by, you replace theta or the funny looking symbol with that value. As simple as that. And what you want to do now is type in each one individually on your calculator. Everyone typing cosine 90, just press the cosine button on your calculator, 90 and equal. Just press cosine 90 and equal and tell me what number you see on your screen. You're getting 0? You're supposed to get 0. Eh? Cosine 90 is what? 0. Type in this one now. Minus sine 90. Now, this minus sign is not the same minus sign. On your calculator, you're supposed to have a positive / negative button or a minus sign in brackets. Press either of these buttons, sine 90, and tell me what number appears on your calculator. Minus sine 90. After you type that and press equal, you'll see -1 appear on your calculator. Now type in normal sine 90. In this one, you don't have to press the minus sign. Just press sine 90 and equal. And what you see on your calculator. Sine 90 is +1. And type, well, we all know what we're going to get when we press cos 90 because we did it first here. Cosine 90 is 0. Now, if you're not getting those values, it's just simply because your calculator on the wrong mode, and you just need to do some research on how to get it back on the correct mode. But for the time being, let's just pretend everyone could type it in on a calculator, right? Resolving how to use a calculator after class won't take you too long, okay? So you see this matrix here, 0, -1, 1, 0, 0, -1, 1, 0. Let's put back all the coordinates here, right? So you can see it clearly. Guess what? If we take this matrix, 0, -1, 1, 0, and we multiply it by all the points, and we plot the new points, guess what? It will look like the triangle got rotated by 90 degrees. We have to do all the calculations one by one. Do me a favor. Take this matrix, the one we now calculated, and multiply it by point A. A is how much? 4, 6. Put the 4 on top and the 6 underneath. Multiply this matrix by A, and you will get A prime. Everyone do that quickly for me. And then we're going to do it for B. And then we're going to do it for C. And then we're going to plot all 3 points and see if it really, really looks like it got rotated by 90 degrees. Now, I'm not going to do the multiplication out step by step. I think we passed that point in class, and everyone should be able to do what? Multiply the matrices after 3 weeks of preparation. Good luck. And I'm going to have to erase everything on the right-hand side of the screen just now. So take down what you need to take down. So when we take this point, 4, 6, right? And we multiply by this matrix, did you all get -6 positive 4? How much of you all got that? Keep checking it. It's -6 positive 4. But like I said, I'm not going through the multiplication of matrices. This is where I have to make the assumption everyone came prepared for today. Let's plot that point. Number -6, 4. The top is x and the underneath is y. -6 on the x, and we go up to positive 4. So this is A prime. -6, 4. Do the same thing for point B now. Take point B, which is 7, 1, multiplied by the same matrix, and get B prime for me. You see, this particular matrix is going to take each point and rotate it by 90 degrees anti-clockwise. Doing it slowly here for you guys. Take a minute. If you take point B and multiply by this matrix, you're going to get -1, 7. The top is the x, the underneath is the y. Let's go to -1 all the way up to 7. That's somewhere up here. And guess what? Do the same thing for point C now. Take point C multiplied by the same exact matrix. Point C, which is how much? 4, 1. And get C prime for me. Right, take a half a minute. All right, so I think we're going to get -1, positive 4. -1, positive 4. All right, and if you connect this, does it look like it got rotated by 90 degrees? Is there a way to check that it got rotated by 90 degrees? Oh, by the way, this formula only works if we rotate it about the original, I forgot to mention that. The examiner is supposed to say that. So that means all the rotation is taking place about the origin. Obviously, rotations could take place at a different point other than the origin. But this formula only works if it being rotated about the origin, and the examiner have to specify. Now, how do we check to see if it's actually 90 degrees? But there's a real easy way to check. All you have to do is to take two similar points. Take point A, right? This is point A, and after A was rotated, right, it ended up over here, right? Everyone agree with that, right? I'm gonna use two different colors. I could probably use a deep pink. Hope you, that's not terrible. Anyway, I hope you all can see the deep pink there. All we have to do to test to see if this is really 90 degrees is take our ruler and connect it to the origin. So you take the original point A, take your ruler and connect it to the origin. And when it hit the origin, pretend it bounced off and go to where it was. Does this angle look like 90 degrees? Look at it. Does that angle look like 90 degrees? Yes. So that's how you do the test now. And you can do it for any pointer. Like you can take point C, connect it to the origin. When it hit the origin, let it bounce back to where it is now. And look at that blue line. That blue line looking like 90 degrees, right? And if you do the same thing for point B, connect point B to the origin and let it bounce to B prime. And the two lines will look like 90 degrees. So that's a little test now to make sure you actually did it correct. Okay? All right, for those who need to screenshot, you can last door. All right. All right. We're not gonna be able to finish the story today, but so Jenny goes to meet the count, right? Remember, he's Mr. Amasos. All right. Now this one I wasn't able to put in the voices, but when she went to meet the Baron, the conversation went like this. He asked her to marry me. She says no. So he says, marry me, please. And then she says, I would rather die of some disease. I know what a pro. Yeah. And then he says, I'm telling everyone you're a witch. And then she replies with, oh man, I always knew you were a snitch. So things didn't really go too good there for Mr. So Smelly. But next week, we will have the conclusion to this story, right? And we will see what happens to Jenny. All right. So guys, thank you. Thank you for coming to today's class. I hope you all enjoyed it, right? Please revise as much as possible, right? And I will see some of you all tomorrow for physics, I believe, and whatnot, right? Take care all. Have a good one, right?